All right, hey everybody, Mr. Fortin back here. This is your last problem on today's asynchronous problem set. This isn't due until Tuesday, so hopefully this wasn't too much work for you here. But anyways, this problem I want to go over this one here because this isn't quite combining like terms, at least not on parts A and part C. It's a little bit different. Okay, so I just filmed that video just like 30 seconds ago for me here on 333. So please watch this here. I talk about ordering of polynomials, right? When you simplify it. So here's your answers to these. The order does matter a little bit here, writing the most simplified polynomial expression for those as possible. We're going to do these ones here. We're not going to worry about ordering because our answers are all going to be one term here. Okay, so check this one out here. Simplify each expression below if possible. And yes, we can simplify all these. It's definitely possible for all these because here we just have x. All of our variables here are x. So we're going to be able to write these a little more simply. Here we got 5x's, but it's being multiplied to 3x's here, okay? So this one's a little bit tricky. I'm just going to give you the answer kind of and talk about it a little bit, justify it something. And in my last video, I talked about the commutative property of addition. That means, right, what commutative property, okay? There's commutative property of addition and of multiplication, right? They're different properties, but commutative property of addition means when you're adding, order doesn't matter, okay? So 3x plus 5x would be the same thing as 5x plus 3x, right? That's what we did a second ago here, okay? We have three of our, I got two here, but we have three x pieces, and we're adding to 5x pieces. How many x pieces in total do we have? We have 8x pieces. And that's no different than if you had 5x pieces, and you're adding that to 3x pieces, okay? So when you're adding expressions, order doesn't matter. And that's what the commutative property of addition is, right? That's how you move stuff around, okay? So our answer here is going to be very simple, right? This answer here, B, is 8x. Okay, we're good to go here. This problem right here, I'm going to think about this problem here in terms of another property called the commutative property of multiplication. Okay, of multiplication here, okay? So when you multiply things, also, order doesn't matter, right? Order doesn't matter. So if we're sticking with this 3 and 5 thing, we actually have 3, 5 here, we have 3, 5 here. 3 times 5 is what, right? 3, 5 times would be, get us to 15, right? 3, 6, 9, 12, 15, right? That's 3, 5 times, gets us 15. And then 5 times 3, right? That's 5, 3 times. Okay, so 5, 10, 15. They get us to the same thing, right? 3 times 5 equals 15. 5 times 3 equals 15, okay? So commutative property of multiplication is when multiplying, order doesn't matter either, right? Order doesn't matter either. 9 times 6 is 54. 6 times 9 is 54. Got those multiplication tables. What else is we got here? Well, multiply 3 times 7, 21. Right? 7 3 times, right, would be 21 as well. So this expression here is everything's just multiplying here. We got 5 x's, right? That just means 5 times whatever x is. If x is 10, that'd be 5 times 10, and then 5x would equal 50. And then if this is 10 here, right, this would be 3 times 10. That would be 30. And then what would you do? You do 50 times by 30. 50 times by 30. So just a whole bunch of multiplication in a problem like this, okay? So I might rewrite this one so you can see why this is so, but the idea of this, when I have like this polynomial expression, well, with no pluses and minuses, I just got multiplication here, I get multiplication here. We can think about this as just 5 times by x, and then this is parentheses right here. So I could just say times by, and parentheses, this is just multiplication in parentheses. This is just a single term here. I can just think about this as times by 3 times by x. Right? 3 times x right here. Okay, so here we're just multiplying everything together. That's it. Why did I mention the commutative property earlier? Is because when you multiply, what's the deal with ordering? Does it matter at all? No. When you're multiplying, order doesn't matter. So I'm going to do this so you can see it here. This will be like a slower way of doing this. We'll do it faster later. But if I move this here, if I move this 3 next to this 5, we're going to see clearly that we're going to have to multiply those together. And we're going to get what? We're going to get 15. We'll get that in a second. Okay, so I move that over here. That means I'm going to shift this x over here. And over here, I got x times x. And that's a little bit different. But perhaps you know what x times x is. What logically would x times x have to be equivalent to? Well, what's 5 times 5, right? 5 times 5 is 25. What's 2 times 2? What if x were 2? 2 times 2 is 4. What about x? X is 3, right? 3 times 3 is 9. So 4, 9, 25, what do they all have in common? 4 times 4 is 16. 4 times 4 is 4 squared. 3 times 3 is 3 squared, right? 9. 2 times 2 is 2 squared, right? 4. So this here, x times x is x squared, right? Is x squared. X times x, right? We got a square here, right? Where does that come from? Well, we have a square with a width x and a height x. Area is going to be x squared, as we've been dealing with the area model recently here. 5 times 3 is 15, and we got our answer, okay? So looking back at the original problem, okay, 5x times 3x, to quickly jump to your answer, all you got to do is multiply the numbers and variables. That's it. Right, that's it here. That's your shortcut here, okay? Let's look at this one. Let's do this one. This one's pretty easy then if we think about it this way. Well, this would just be 6 times 6x times x. 6 isn't multiplying to anything. There's no other ones there, okay? Or there's an invisible one there, but 6 times 1 would just be 6, so we don't care about that. So here we just got 6 times x, and that's just 6x squared, okay? 6x times x, well, x squared right there. Those are unlike. They don't need to multiply each other. So you're kind of multiplying the like terms, to be honest. X and x becomes x squared. Or you can actually multiply x times x squared too. That's the difference between that multiplication and division. Because x times x squared would be x multiplied to itself 3 times total. Okay, we did exponents earlier in the year. All right, we got this. And then finally, last one here. This is really easy, 7x. Okay, so notice here, right? Answers are different. Okay, 6 x's total. I got 6 of my little x's here. I've got 1 other x over here. Bring them together, combine those like terms, 7x total. And we got the answer here. All right, email me if you have any questions. Yeah, it's pretty straightforward if you went through it with me on that one, and we'll practice this. We're going to do lots more multiplication of polynomials, and it'll get more complicated soon. And that's why we're spending time with tiles now, this week and next week. Have a great few days. I will see you guys on Wednesday. Bye-bye.